This is stage 3 of the wheel demonstration. The overall purpose of the complete demonstration is using our tribrid modelling, that's working with surfaces, solids and triangles, to reverse engineer an alloy wheel, then to re-engineer the design features. During this stage we shall take our wheel model that was reverse engineered from scan data. We shall then modify some of its design features to re-engineer the design of the wheel. We shall be demonstrating re-engineering techniques, solid filleting and other solid editing functionality. If you click on the image of the model that is associated with this demonstration in the rolling demonstration HTML, it will load in this model. We can see we have the created solid design. If we turn off this level, we can also see we have the triangle scan data from which it was created. If we open up the solid history tree, we can see how the hole features were created in the wheel. We can right click on it and select modify. And for example of re-engineering, we may want to change the existing number of features from 6 to 10. This will quickly and easily recalculate the hole features in the wheel solid. If we turn off the triangle scan data, we can see the effect this has had on the wheel. We can close our solid history tree window now and open up our solid filleting form. We can select the edges here, and we can shift and select a number of edges around the model. This has created a neat fillet around the whole features of the model. Next, if we turn off the wheel model, turn on level 100, we can see we have a model of the hub and drive shaft assembly. These obviously currently intersect with our solid model, and we need to create some holes in the model to allow for the wheel studs. So if we activate our workplane bolt hole center, we can turn off level 100 and turn back on our wheel model. From our solid feature menu, we can select to create a hole in the model. Using the intelligent cursor, we can snap to a key point. View in Y. We can also view in wireframe shading. We can see how the hole is going to be created through the model. We can then carry on to begin defining the parameters of the hole. If we turn on our solid shading now, we can see the hole that we have created. We can then activate the work plane in the center of our wheel. If we double click on the solid, it will open up our solid history tree. We can select the hole that we've just created and then select to create a pattern from that hole and the number of times we wish to repeat it around this work plane. We can close the history tree. If we turn on level 100 again, we can see that we have created the necessary bolt holes to attach the wheel to the hub of the car. If we move along this bottom line now, we can activate the rest of these levels that will turn on different features and parts of the wheel assembly. We can then turn on our enhanced shading and look at the wheel that we have created. So we have seen how we can use the tribrid modelling functionality from within CopyCAD Pro to easily reverse engineer a wheel from scan data and then re-engineer the design of that scan wheel. That is to change specific design features of the wheel. We've seen re-engineering techniques, solid filleting, and other solid editing functionality.